Example 4. Multiply 4 plus 2i times 3 minus 2i, multiplying complex numbers. And this is just a FOIL problem. So I'm going to multiply 4 times 3. Real times real makes real. Outside product, real times imaginary makes imaginary. 4 times negative 2 makes negative 8, and then the I is attached to it. Inside times inside, positive times positive, real times imaginary can make a positive imaginary. And then imaginary times imaginary, 2i times negative 2i makes negative 4i squared. When you're doing a regular complex number times a regular complex number, so I'm talking about just integer plus or minus integer I. Alright? When you're looking at just basic structure like this, you should expect 4 products, which would be 1 real, 2 imaginaries to the first, 1 imaginary to the second every single time. As far as whatever order it's in, maybe we got one of these swapped around and so you get the I squared somewhere in the middle, whatever. But you should get 4 terms that look like this every time. 1 real, 2i to the first, and 1 I squared. And the I squared makes what?
Negative 4.
Negative 1, right?
Negative 1, sorry.
We multiply by negative 4, so negative 4i squared actually becomes positive 4. So you get your real, you get your 2 imaginaries, you get another real in disguise. And again, the I squared just changes that sign. So it's negative 4i squared, so it's positive 4. And then once we get our reals and our imaginaries, then again we get a real sum first. Positive 12 and positive 4 make positive 16. Imaginary sum second. Negative 8 and positive 6 make negative 2i. So 16 minus 2i is the best answer for that one. And again, if you get integers only, you should expect binomial times binomial to make a binomial every time. If radicals start showing up in there, you might get multiple terms because you can't add the radical objects together. But as long as they're just whole numbers and integers, you should expect complex times the complex binomials to make a complex binomial.